Okay, so we're to consider a station broadcasting an AM radio wave and an FM radio wave. And in each case we need to find, not send, find the distance between adjacent crests in each wave. So, drawing a simplistic wave, the distance between two adjacent crests is, by definition, the wavelength. So in each case we're being asked to find the wavelength, and in each case we have to look at the information given. So what we know is that the velocity of light is equal to the wavelength times the frequency, and the velocity of light in air, to a very good approximation, is the same as that in a vacuum, which is 3.00 times 10 to the 8 meters per second. So we're asked to find the wavelength, we're given the frequency. If we divide both sides of this equation by the wavelength, then we find that the frequency is 3.00 times 10 to the 8 meters per second divided by the wavelength. And please note that I've done that exactly the wrong way around. I beg your pardon. So we're asked for the wavelength, and therefore we both divide both sides by the frequency. And note that the wavelength will be in meters provided the frequency is in per seconds, which is hertz. So this is just direct substitution, and we don't even have to make any changes in units because the two frequencies have been given to us in hertz. And so the wavelength corresponding to the AM frequency is calculated to be 243, well, 243.9, so 244 meters, and the wavelength corresponding to the FM signal calculates to be 3.03 meters. And just making sure that the poor person who has to mark the work knows clearly what it is that we wish them to mark, and we're done.